Hey, I'm Alex. I'm one of the co-founders and CEO at Snorkel AI. Led the Snorkel project at Stanford prior to spinning out. I'm also on faculty at University of Washington. And I think the prompt question was, what kind of coffee do I drink? So my embarrassingly stereotypical Silicon Valley answer is I actually use a kind of flash frozen coffee called Cometeer. It's awesome if you want to check it out. And basically they ship these little capsules that you run under hot water and just plop into a cup of hot water, and that's what I drink, because it's I wish I was sophisticated enough to have to master the art of making it myself, but that's easy and fast, and it's pretty delicious if you want to check it out. So that's my coffee answer.
Welcome back, everybody. This is another edition of the MLOps Community Podcast. I am your host, Dimitri Os, and I am here with none other than the most incredible co-host, Abby. What's going on, Abby? How you doing?
I'm wonderful. I just finished my workout, came back, took a shower as always.
Nothing better than recording an intro about a podcast that we did a week ago. We've had some time to let this one sink in, and our special guest today was none other than the CEO of Snorkel, Alex. He also has written some pretty incredible papers. You knew him from his papers first before Snorkel, right? I mean, he's been around.
Yeah, I've got a friend who joined Snorkel in 2017, 2018. So I had a chance to read some of his papers and was sort of seeing their open source work from the outside. I wasn't really involved in all of that stuff, whereas just sort of like keeping track.
I love the fact that he is starting to think about foundational models and how MLOps and these gigantic models are going to start playing together. It's becoming one of the biggest buzzy words of the day or of the year, I think. The foundational models everyone is excited about because of their potential. But there was a lot of stuff that we dug into. We got into the papers. We got into just his view on the world. What were some of your takeaways?
So I think the most important parts for me first was our discussions around ensemble modeling, which was how to combine different models, because he was obviously using weak supervision, but he was also starting to combine it with other deep learning techniques to be able to see if they can expand the horizons and stuff. The other is more so his mention of how to actually use foundational models, because I feel like I've been somebody who's been slightly skeptical of LLMs. I mean, all the GPT-3, GPT-4, all that stuff is great, but I've always felt like it was excellent as a hype because of the predictions not being that good. And I was like, so for a high stakes situation, we can't actually sort of use that one.
So true.
He gave a very interesting perspective. He was like, let's use them as base models and do feature engineering on top of it for use case specific scenarios. And that makes perfect sense.
That's so true. And the way that he talked about some of their clients using these models currently, that just shows that it's not all hype. There is value being derived from this. And so I'm excited as to where it goes and what we're going to see in a year or 2 years from now.
The adoption would be very interesting to see on everything.
Yeah, it's going to be really cool as time moves forward. So we got to give a huge shout out to Snorkel for sponsoring this episode. They are incredible. I mean, I've loved Snorkel even before they sponsored this. I think they're doing some super cool stuff. And if you are interested in anything that we talk about in this episode, definitely hit them up. You know what their website is already, but we'll leave a link in the description, snorkel.ai. And I think we might as well just get into it, Abby. Any last minute things that you want to say before we jump into the conversation?
Give us a comment on YouTube, Spotify, Apple, wherever you're seeing us. Give us all the good ratings and really good comments.
Why not share this with a friend while you're at it? That would be incredible.
basically you've been pursuing weak supervised learning, but why weak supervised learning over, say, some other sort of transfer learning or active learning?
Well, that's an awesome way to dive in. So, I think that at a high level, the broadest interest that has kept me busy for the last almost 8 years, which sounds a little not at all depressing to me, although it sounds a little one dimensional if you think about it in one way. But if you think about it another way, it's there's just lots
Dedication.
to explore around. Yeah, and there's lots to explore around data and what we think of as data-centric AI. So I think top level concentric circle. There's and it's not an either or, but there's this split that we make between model-centric development, where you might think of the model being relatively fixed, and the data being relatively fixed. You're iterating on the model. That's what I often think of as the kind of Kaggle era of machine learning, or the ImageNet era, where you just it's what a lot of us started with. If you look at 5+ years ago, every single paper was about features or algorithms or bespoke model architectures. That's what people were doing out in industry if they were actually working on a new problem. And the data was someone else's job. It was something outside of the kind of ML developer's responsibility, right? And so this broader set of things that has been capturing my and now many others' interests, which is super exciting. And the Snorkel team since back in 2015 is this idea of broadly data-centric methods, where you're assuming that the model class can be auto-selected, or you can kind of pick a standard class. That was kind of the forward-looking bet. That's not too forward-looking anymore, given how things have converged in such an exciting way out in the open source. And what you're instead doing is really iterating on the data, labeling it, shaping it, developing it, et cetera. So within that, there are all these methods that you can view from the data-centric perspective. And I'll rephrase them in my own simplistic way, but you've got active learning, which is essentially saying, let's be smart about where we look on our next iteration of developing or labeling data. You've got transfer learning, which is, let's see if we can kind of reuse something from a prior data set or model to kind of jumpstart the performance. And then you have things like weak supervision, which I would phrase as, how can we be radically more efficient and scrappy around how we actually do the labeling once we're looking at something. So you can kind of see, obviously, my way of phrasing it is going to lead into the way we view it, but we view these as very complementary techniques. They're all tools in the toolkit. And it's worth noting the kind of, at least the cautionary note I'd give first, which is that, each one of these, you can find instances of them being pitched as magical silver bullets. And those kinds of, free energy machine pitches don't really help real practitioners. That's our strong perspective after 8 years of working in the space. Active learning has been around for decades. Amazing progress in the field. I have a grad student I get to co-advise at UW who just published a paper on active learning plus weak supervision, actually, with some cool results. But it's not a silver bullet. Even if a little theoretical intuition is that deciding where you need to look next in the data is often as or more difficult than actually deciding on the decision boundary that you're trying to build and, say, training a classifier in the first place. In other words, intuitively, if you knew exactly where the model needed more signal, that's as hard or harder of a problem than actually training the model in the first place. You don't know what you don't know, so to speak. And so these are all really helpful techniques, but they're not silver bullets. And our view is, and this is what we've both put out research around, but also build around in our commercial platform, Snorkel Flow, is that they all work together. So, in our conception of a data-centric, iterative workflow, each iteration you're saying, how can I label or otherwise improve the quality of my training data? And active learning guides you to where to look to go next. Where should I label by hand? Where should I label programmatically or with weak supervision? Where should I debug or edit? And there are a whole bunch of ways of doing that, but that's the kind of the where do I go next? Then there's the how do I label? Do I go through and kind of click one data point at a time in the kind of legacy manual labeling approach, which can be appropriate and inevitably is part of the process in tough problems. But then the weak supervision question that we've been working on for years is, can I be more efficient? Can I write functions that label data? Can I even use things like foundation models or large language models, which I'll take a wild guess we'll get into in our discussion today. And that gives a hint about how we
not?
Yeah, how could we not? That gives a hint about how we think about fitting it into this data-centric workflow. And we can talk about why. But basically, how can we use all these more efficient ways to label the data also more maintainable ways, things that look more like labeling your data with code, so you can now edit and change and share and reuse and govern, which you can't do with big piles of manual labels. And then transfer learning, we think of as just a way to kind of raise the baseline that you're starting with, right? So whether it's classical transfer learning or it's zero shot or few shot methods, which, surprise, surprise, will again take us back to foundation models if we dive in there. That's the kind of, okay, how can I start with a baseline performance rather than starting from scratch? That's actually why myself and my co-founder Chris, who's was part of starting up the Stanford Center for Research and Foundation Models, likes that foundation model term, because we think of it as foundations. They're kind of sturdy generic foundations. Then you still have to build your specific custom building or house on top, but you want to start with those strong foundations. So to summarize, transfer learning, think of it as kind of your warm start versus your cold start, your kind of base. Most problems are not magically solved by transfer learning if they're complex and non-standard, right? Most problems are not solved by zero few shot learning when they're actually kind of tough, high value, bespoke problems on custom data sets, custom objectives out in real industry. But they're great. It's a great way to start. Active learning is kind of the where do I go next to label or improve my data, and weak supervision is how do I label my data in a more efficient and maintainable way. So a little bit long-winded, but that's how I see them all fitting together and playing nicely together.
And there are two ways to go from here. One is we directly jump into the foundational models, but I had a few more questions about your papers. So I'll ask you the questions about papers, and then we can go into detail on foundational models. So one of the things, I was reading your paper on Nemo, and you were talking about labeling heuristics and how to allow users to participate or inject their knowledge into the labeling process. Can you talk a little bit more about that one?
And Alex you thought that we were going to do pleasantries and say hello and go through what's your background? We just jump right into it, man.
I didn't even get to do a proper intro. We hit the two hardest hitting topics I can imagine. Sick kids at home from preschool, disease vectors, and then straight into paper interrogation. I love it. I'm Alex, by the way. I think there's our intro. But let's dive right back in. This is the fun way to do it. So the Nemo paper, this is from a student I get to work with at the University of Washington, Chang Yu, who's awesome. This is actually what I was referring to when I said the kind of recent work on active learning plus programmatic supervision. So the idea at a high level in Nemo is it's kind of building on this Snorkel programmatic supervision line of work, where you start by, you label data by trying to write a function rather than just labeling individual data points. And this function we've usually call labeling function, labeling heuristic. Sometimes we vary up the names to try to make the academic work more generic. But I'll refer to it as a labeling function here, which is our standard terminology. And the idea there is like you said, it's a way of injecting domain expertise. So let's just focus on that part. This is kind of the Snorkel idea, and then we'll talk about where active learning comes in the Nemo work. The basic idea here, one way to motivating is actually how we started with the Snorkel project, or one of the motivations. It was this awesome project through DARPA that we were funded under DARPA Simplex, and they paired us with what they call SMEs, or subject matter experts. So we were working with some genomicists, some collaborators at Stanford. They do some awesome stuff on pediatric genomics that actually has interventional impact. So really, really exciting, motivating projects. Unfortunately, they can't solve the common cold in 2 to 4-year-olds like we were talking about at the beginning.
Dude,
but
for some random person that just drops in on this, DARPA working with SMEs and the genomics or the nomics. If you were just a little bit outside of the box, it's like, wait a minute. Is this some role play game that I don't know about, or RPG?
How did we get here?
Yeah, exactly.
How did we get here? Well, it's like I get the hard hitting questions like setting up flares, all the random other pieces. But no, I'll arc back to our MLOps and Geocentric AI bit, which is that a lot of what we spent time doing. This is when the data-centric stuff started to hit us in the face. Bulk of the project was not building our fancy machine learning models back then in 2015, 2016. That's what we kind of thought we should be doing as ML researchers. Most of the time was spent labeling and relabeling and debugging training data and error modes of the model. And all of it consisted of sitting there with a SME saying, okay, the model labeled this, but you said this. Why is that wrong? What features are we missing? What things are we missing? And then, okay, let's label this data. And the really interesting thing, we did, multiple sessions a week, is that as they were labeling data, these collaborators were talking about why they were labeling the data. Well, I see this negation here, and I see this kind of phrase, so I know it's this kind of thing versus that kind of thing. But then all of that information was getting thrown away and not passed on to the machine learning model. All we were giving the machine learning model was just the XY tuples, here's a data point, here's the label. So a lot of what we've been pushing on for many years now, you can view it, almost as just saying, let's not be egregiously wasteful with this labeling process. I mean, this API of all that you pass to the machine learning model is a data point and a label for supervised learning has been incredible for the field. It basically has let people do their model-centric development and not even think about the data and all the domain expertise that goes into it, which for a period in the space, I would argue has been amazing. It's led to this gold rush and boom of model progress. But if you think about it from a real world sense, why are we playing like 20 or 20,000 questions with a machine learning model? Our SMEs, the people who are labeling the data, they know all this information. They know that I'm going to label it here because I see this key phrase. I'm going to label it this way because I see this pattern, or I reference it with this external resource or whatever it might be. And then we just throw it out and we ask the machine learning model to try to statistically re-infer it. Why not just give it to the model? So that's a little bit of a long-winded arc of saying, what is this idea of a labeling function, this programmatic supervision or weak supervision? It's that we can label training sets often 10 to 100 times more efficiently measured in time taken to do the labeling by just giving more information, labeling with functions or heuristics or patterns rather than just by hand, and accepting that it's going to be a little messier than individual data labels. And we're going to have to clean up that messiness algorithmically, which is the weak supervision part. So I'll take a brief pause there, and then I can get to the Nemo paper, which, well, I'll give the quick bit there, which then ties into active learning, which is basically saying, okay, that's going back to where we started. That's the how do I label? Let's get richer information from our experts who are labeling the data in the form of a labeling function rather than just click, click, click. But still, we can also be smarter about what data we show those people to label next. So regardless of whether you're just clicking and labeling in the legacy way or you're writing a labeling function to give richer information, you can still be smarter about where you look next to build that. These labeling functions don't just come in a vacuum. They come from looking at the data and saying, oh, I should label it this way, or et cetera. And so the Nemo paper combines the two and says, let's both be smart about how we label and where we label on each turn of the crank.
Very interesting. And this also ties up with another thing you talk about, geocentric AI, and something which has been my personal experience, which is often the model you pick, whether it's for classification or regression problem or even for labeling, it depends very heavily on the data itself. And in your original Snorkel paper that you published in 2017, you said there are two directions from here. One is we figure out an end-to-end system for data programming for textual data. And the other is we look at different modalities, including images, video, etc. Would it be fair to say weak supervision works very well for textual data and may or may not work? I don't know the research on that one, but it doesn't work equally well for other modalities.
So we started in text because we're big nerds around a lot of the really exciting problems in natural language processing and knowledge extraction, which is a lot of what we worked in. There's such a gold mine. I mean, I could drone on about this too, about, all this information that's kind of more accessible than ever before in one way. You can, I won't, repeat the kind of, market stats on data availability. We know there's a lot of data out there, more accessible than ever before, but it's also the knowledge in that data is so inaccessible. So a lot of what we started with, what we do today is all about, classifying, tagging, extracting, pulling structured, usable data out of unstructured data, whether it's, a bunch of scientific papers, back in the Stanford days, or whether it's multi-100-page contracts in a bank or an insurance agency, et cetera. So that's where we started. But image has been a big focus. Actually, my co-founder at the Snorkel company, Paroma, did her whole PhD, or the big applied focus was on image and video. And I think we've actually published more papers, especially on the medical side, a couple of Nature Comms papers on image and video and weak supervision there than we even did on text, which is a weird artifact, but it is true. And so we're actually really excited about progress there. And actually that takes us to one thing that we've been teasing, but I know we want to talk about, which is foundation models today, which is how foundation models we see fitting into this picture. I'll just preview that a lot of the image use cases are accelerated by these foundation models as well. So one way that we'll get to, I want to take it top down, but this idea of a labeling function, you can kind of think maybe in more simple ways about, in text, I'll look for a pattern, or I'll look for a key phrase or something like that. But in both an image, that might seem harder. How do I do that over pixels? There are answers to that. You can run feature detectors or object detectors to give you building blocks that you can then write labeling functions over. That's some work we published in 2017. You can use metadata that may be textual or structured, but you can also now use labeling functions based on foundation models that allow you to kind of write heuristics, write labeling functions over image using some of these great either image-based or multimodal foundation models that give you these kind of powerful ways. You can literally just write a natural language prompt to write a labeling function over image now, given these amazing models. And so the foundation models play a big part of that strategy as well, which is why we've been seeing some exciting image results and are rolling that out also now on the company side.
I love that. So one thing that I think foundational models do not get enough credit for is the use cases around enterprise, like actual things that make money, right? Like you hear a lot of people saying, oh, well, yeah, foundational models are great if you want to make a cat riding on a rocket going over the moon. That's cool. And it just gives you some picture, or it's doing some, like Runway ML is doing some insane things when it comes to video. But when it's like, but let's get down to business and the adults in the room still need to predict fraud, you can't do that with the foundational models right now. I think you have a bit of a different opinion. Like you know enterprise use cases when it comes to foundational models. Can you break some of those down for us?
Yeah, I think it's a great prelude, because there's incredible excitement and incredible real value and magic in these foundation models and the way that they've gotten scaled up, and yet we see such a gap between that and real enterprise usage. And so the fact that gap exists, it is very real from what we see. Right, we work with a bunch of the top U.S. banks and government agencies and insurance, healthcare, telecom, across a lot of verticals, and in a lot of these settings where there's high business or mission or patient value, which high value also goes with stricter constraints and greater consequences and governance strictures, et cetera. You don't see foundation models being used, and so let me take a step back and give our view on this from experience in these use case settings. And I'll characterize kind of two gaps here around the challenges of adaptation and deployment. And those two things, adapting foundation models to these, to the challenging custom use cases that have high value in enterprises, and solving the deployment challenges of how do I actually serve, a foundation model in production. Quick preview answer is that most enterprises can't and don't think they will be able to for a couple of years, for not just cost and latency, but also governance reasons. So how do we solve those adaptation deployment challenges? So let's talk about the adaptation one first. There's and I can start with an example, but one way of viewing it is that if you have all of these kind of generative, creative, exploratory use cases, I want to generate that, the cat on a rocket ship going over the moon, or I want to generate some copy text that I'm then going to edit. Foundation models can do amazing things right out of the box in this kind of human-in-the-loop kind of procedure. One way of thinking about it is there are looser accuracy constraints there because you're using it as part of a creative process, not as something that has to spit something out with a certain high bar of accuracy, right?
Yeah.
Versus
you're augmenting humans' abilities as opposed to replacing it.
Yeah, and it's super exciting, and I'm personally a big fan of on the amateur side of those loops, and I've been playing around like everyone else with these models. But that's very different from the kind of automation or what we would more technically call discriminative versus generative use cases, especially in complex settings where you have to achieve a high accuracy bar, and also you have to do it in a setting that is not the same as the data these models are trained on web text, right? So that let me give an anecdote really quickly. This was I was playing around actually early on with Stable Diffusion to get a little Snorkel logo. You can see this is a Snorkel logo wearing a spacesuit for one of our internal hackathons. But I was saying, okay, what can generative AI these days with foundation models do here? So I had an awesome experience. It was really exciting. I went through about 30 samples until I got something that looked pretty cool. I couldn't get the octopus wearing the snorkel underwater. Maybe that was too far outside of the support distribution, but I got a really cool image. So from a creative generative workflow, that was a big success. But if you think about it from a kind of production automation or discriminative modeling perspective, one success after 30 tries is like a 3.3% kind of hit or accuracy rate, right? That's abysmal. So how do you get from one to the other? And how do you kind of bridge that gap, which is both about, tuning the accuracy and then doing it on very bespoke use cases? We should always be very careful, I think, about drawing analogies between AI and humans, given how dumb AI still is and how we're still struggling to solve very simple challenges in real production use cases. But one analogy is kind of generalist to specialist. If you have someone who's learned to read on Reddit and the internet, you wouldn't expect a human to be able to just suddenly read multi-100-page contracts or analyze very technical fraud or network telecom data right off the bat. They would need to have some adaptation, some tuning, right? So this gap from generalist to specialist and from kind of loose accuracy constraints in the generative world to high accuracy bar in the discriminative world, that's this kind of adaptation gap. And the standard way of crossing it is by fine tuning. This is an old transfer learning concept, right? You just fine tune the model on labeled training data. And once again, you're back to this data-centric AI problem. You can do prompting and zero shot or few shot techniques, but most studies showed and our internal results also corroborate that if you want to get on these very tough problems to high accuracy, usually you're just going back to fine tuning on labeled training data. Probably less than if you were starting from scratch, but still for these bespoke problems, quite a bit. So our view is, surprise, surprise, that this adaptation gap once again comes back to data-centric development. You're not when you want to do this adaptation gap, you're not going, another way of thinking about it is you're not going into the foundation model and tweaking some of the multi-billion parameters. I mean, there's some cool work on patching and stuff that's going on, but you're kind of leaving that. You're fine-tuning, you're adapting, and that's all about labeling, editing, developing data once again. So you've got this big adaptation gap that a lot of people, that's at least how we frame it, crossing this gulf from generative to discriminative or prediction automation. And also crossing from kind of generic web text where all these models are trained to custom settings or specialist settings. And then the other one that I think a lot of people underestimate is this deployment gap, which is that, I talked to one of our customers at a large top 3 US bank, and they said that they were they were thinking about submitting something to their model risk management committee about getting GPT-3 in production. And they likened it to an art project, kind of a Don Quixote, like tilting at windmills activity. So this was their pessimism about when that would happen, given that there's still even challenges getting modern deep learning models kind of through to production. And honestly, there are cost barriers. These things are very expensive to serve. There are latency barriers. They take time. We're going to chip away at that. One of the biggest ones is when you also throw in governance, because we are just beginning to understand these large foundation models. It's actually doing really exciting things on the academic side where it's almost like a return to natural sciences world where you're kind of poking and prodding
Yeah.
empirically rather than just reasoning formally. But
Yeah.
I think enterprises are justified in saying, hey, we have to understand a bit more before we just kind of serve GPT-3 to customers, even if we can solve the cost challenges. So you've got these adaptation gaps. How do we do the data center development to adapt these models for these very specialist high accuracy bar settings? And you've got these deployment challenges around how the heck do we actually put this into production the next year or two or three in these large enterprise settings. And so this is something where we have an opinion, as you could guess, and we're actually are going to be announcing what we call our support in platform for data-centric foundation model development. And the basic idea here is, first of all, for the adaptation, all that fine tuning, that again is where we've been working for years about how do you make data labeling and training data development as rapid as possible through programmatic techniques and active learning and transfer learning and all these things. And the deployment gap we solve by actually using these foundation models to help us label data, which we can then use to train smaller models that fit into our deployment paradigm. So one cool setup, we're going to it'll be up soon, a case study on some public data that we can really share the full results. It's like a 100-way classification problem on contract. So still even simpler than some of the ones you see in production, but a little bit more representative. And the cool thing is if you take a baseline of fine-tuning GPT-3 on a bunch of manual labels to get to a high accuracy bar, using our approaches, you can use less than 1% of the ground truth labeled data and actually train a model that is over 1,000 times smaller and hundreds of times cheaper to run to actually go to production. So think of it as you're using these big, bulky generalist foundation models to help accelerate data-centric development of smaller specialist deployment models that are both more accurate with less input, but also far cheaper. And again, this may sound like it's too good to be true, but it's really that generalist to specialist divide, right? In an enterprise deployment setting, we're not looking to have this gigantic generalist creative machine that we can query for anything. We're looking to solve one task on very custom data, very custom objectives with high accuracy and repeatability and ability to apply proper governance. And so what we're trying to build is we're aiming to be that bridge between all this foundation model goodness and these actually deployable models in these production settings, if that makes sense.
I love that. It's like this offspring of the foundational model or the child of it in a way. And you've got your mini foundational model almost, but you're echoing something that I was just talking to a buddy, Danny, yesterday about, and he had worked at Google, and for like 8 years, he was working with researchers on trying to figure out ways to get their foundational models, like finding ways to put them into products, right? That was one of his main things, was syncing between the engineers and the researchers to find different ways to get those foundational models into the different Google products. And one thing that he talked to me about was he was saying how with these certain types of models, you have to be okay with that lower accuracy score. And you also have to be okay with the idea of the risk of error or cannot be high stakes. Like what you're putting this into play for, it cannot be high stakes because that accuracy score is so low. So you can't do it where it's like we were talking about with these fraud detections where it could really mess things up. And so he made the comment of like, social media, you could throw it in there because if somebody sees the wrong post, whatever, it's not really ruining anybody's day just because of one wrong post or whatever. So now it feels like, though, what you're talking about is much more, let's figure out how we can take these gigantic models that are covering so much surface area and then take the pieces that we like, extract those pieces that we like, use the foundational model to train those pieces that we like. And then we can have that higher bar and we can put it into much more high stakes settings.
Yeah, exactly. Said said even better and more succinctly. Actually, we may share this contact. Because I also we had a Dan from Google Research who worked in this area come by the lab a couple of years back to give a talk, and
No way.
I won't do full names on podcasts, but
later we can talk. Yeah.
Yeah, we either have definitely heard about this. Now taking a step back, just even without my at least without my metaphorical snorkel hat on, because I'll keep my literal hat on right now. I desperately need a haircut, but strict orders from the wife: just keep your hat on whenever you can.
Especially on video.
Yeah,
that's gonna go out onto YouTube.
Yeah, I think in general, thinking of these settings where I often think of it, like it doesn't have to be perfect accuracy, or you're kind of competing against a null baseline. I think in general, these are great places to apply any type of machine learning, especially these foundation models where they're not tuned and very flexible, but not at this kind of like accuracy SLA bar. So I think that's a good strategy to keep in mind in general, right? This is why a lot of ML projects I think are really successful in things like let's take our work we've done in the medical field. We did a lot with radiologists at Stanford and VA Healthcare. We did stuff around triaging rather than automation. We said, okay, like let's triage a queue that's backlogged because the baseline is just nothing. It's just the doctors reading the order that came in. So any improvement is better versus, okay, let's take on full responsibility of automating what a doctor does, which is a big consequential bet to make. And I still think we have a ways to go there. So I think in general, it's a great kind of divide to think about. It's definitely what we see for foundation models too, right? If you again, think of these are these big generalist generative models that are amazing in what they can do, but they're not fine-tuned or specialized to get amazing accuracy on some specific task. In fact, even making them kind of better on generalist tasks often requires fine-tuning. Like there's the FLAN results that came out from Google recently, and what did they do? They fine-tuned on all these tasks. So actually, you see in the broader space, of course, I would say this. I'm talking my book. I'm sticking to the data centric shtick. But even in building these generalist models, you see a lot of data centricity in the thinking. Right? Everyone's kind of converging on more or less the same architectures. There's obviously amazing engineering work that goes into it, but you look and see you look at some of the models that come out. You look at the Stable Diffusion release. You look at some of the one of my colleagues, UW Ludwig Schmidt, published some interesting work with his team on clip models. OpenAI Whisper is another one that has some good details in the data. All these models, FLAN, they all one of the biggest vectors of innovation is how you curate the data going into training them. So even in getting these foundation models built, we're seeing, surprise, surprise, the data they're trained on, the curation of that, right? Stable Diffusion, they had a separate semi-supervised model where they labeled data to look for beautiful images and then bootstrap this model to sub-select down to a training corpus of nice-looking images, right? So, you even in just building the foundation models themselves, you're already seeing, data-centric iteration, data-centric development being key. So, we're just saying, okay, now when you want to take that next step of actually putting them into a production setting, a specialist setting, once again, it often comes down to the data, both to fine tune them, but also to be this kind of bridge into a deployable artifact that you actually, can put into production today.
Very interesting. And this is one thing I often think about, especially because as a developer, the foundational models are very interesting. You get a pre-trained model, somebody's spending up the money and giving it to you to play with. That's all cool. But when it comes to, hey, are these the best models to work with for actual business problems? I am often questioning, is it the right way to just be able to increase the number of parameters and just optimizing further? Should there be better models, or should we be putting more research into better models that are generally optimized for these kind of solutions? Given we've already done a lot of work in meta learning as well as generative models.
Yeah, I think we're going to see progress from all kinds of directions, right? So I think, and you tell me if I'm misunderstanding some of the points you're making, but I think we're going to kind of see chipping away on one end of making these models more specialized and making them kind of better for subdomains, right? Like a legal, a medical, GPT, whatever it might be. And then, on the front lines of kind of trying to get these productionized, what we're trying to do is just, find good ways to use them now. And actually, going back to what you were asking about on our the first question about, weak supervision, and this idea that has underscored a lot of our work of, labeling data programmatically and then being able to combine multiple imperfect signals, which is kind of the crux of the thinking there. That's part of how we got so excited about foundation models and this way of using them, because you're right, as a developer, what foundation model should I use? What's appropriate? First of all, there's an exploding universe of them, right? And especially in the open source now, which is fantastically exciting. And then now on top of it, you have all these different ways of prompting them, right? Which is, of course you have fine tuning, you have few shot learning now, but now the zero shot technique of prompting is, there's, new weird little, prompt sentences you have to write every single day coming out. And so how do I actually now develop the prompts to kind of coax the right information out? Well, in our weak supervision formalisms, that's just another type of labeling function. And this is actually one of the features we're releasing. There are actually kind of three that we call. One is fine tuner. So just we're adding support in Snorkel Flow to fine tune some of the newest breeds of foundation models. So if you actually can ship a foundation model to production, now we can let you fine tune that with this programmatic data approach that we support and have built. And then we have these two other features called warm start and prompt builder. So warm start is basically just the kind of what I was talking about transfer learning as a kind of a bootstrap baseline, using foundation models with zero shot techniques to just auto label your data as a first pass. On one of these specialist production problems, they're not going to get you up to the accuracy level on all but the simplest of problems. Like, for example, we were using this with a large bank who's a customer on an anti-money laundering and know your customer problem, where they had to pull hundreds of pieces of information out of these big piles of customer documents. So some of the simple things like what's the name, or what is the date on this contract, or things like that, actually just using this kind of warm start zero shot approach could get pretty accurately, which is exciting and you kind of expect. The bulk 80+%, it gave a kind of jump start, but it was nowhere near accuracy level. So you can kind of basically warm start versus cold start your problem and get some of the low hanging fruit labeled, and then you can use programmatic labeling, write these labeling functions to rapidly label the rest of the data up to quality in this iterative approach that we support in Snorkel Flow. But now you can also write what we call prompt labeling functions, which is basically writing domain-specific prompts for these various foundation models to try to label parts of the data set. And then the best part is that all of the weak supervision formalisms we built for years, they're all about, okay, how do I combine all of that signal into my final training set, final model, so that you as the developer don't need to worry about, hey, should I be using, this, GPT-3 or Bloom? Should I be using this prompt or that prompt? You just kind of dump them all in, and Snorkel takes care of modeling and integrating them, which is, that's how it kind of fits a little in the weeds, but that's how it fits nicely into the kind of paradigms we've worked on for years. It's all about, how do I opportunistically use all the signal I have at hand for labeling in a more efficient way. And in this rendition, foundation models are just another tool in the toolkit, an immensely powerful one, but also an imperfect and tricky one that you have to tune and engineer, and is not going to work magic out of the box on your specific problem. So why don't you just throw it in with all the other kind of signals in this data-centric workflow? That's kind of the approach we take, and we've been seeing it work pretty well for customers, even in early beta.
So what you're saying is basically use it as a baseline model, the way we use AutoML models to sort of first see the baseline accuracy, and then we build a model on top of it and see, okay, let's do feature engineering on top of it.
Yeah, start with it as a baseline. Again, that's that kind of concept of foundations. And then, do this iteration on improving the data. It could be by writing, engineering specific prompts to kind of fine tune the output of the foundation models. It could be by writing other labeling functions to just say, hey, if you see this pattern labeled this way, using that kind of specialized domain knowledge, and then put it all together. That's what Snorkel does for you, and turns it into a clean training set that you can use to train or fine tune any model that you want for deployment.
I see. Very interesting. Now, I'm going to ask you one more question, one more piece of Snorkel that really excited me, which is basically you now have your own hosting infrastructure, Snorkel Flow. How does it compare against GCP? Because I know your focus was building integration as a service platform.
Yeah, so we deploy and kind of connect with all the cloud environments and all the main ML vendors, and so. The key for us is we just want to support this data-centric workflow. And so we connect to, whether it's a Vertex or a SageMaker or Azure or a home-built machine learning modeling solution. We just want to get you through this data-centric workflow on whatever platform. And we actually run the gamut there too. We have our Snorkel Flow cloud solution that we host, but we also do a lot of, customer VPC on-prem deployments. Actually, because a lot of our customers are working on very, critical problems with sensitive data. That's part of why it's so difficult for them to get it labeled. And it's part of why, the GPT-3s of the world don't work out of the box, because it's this private, custom on-prem data, very critical. So because of that, we're very flexible in the deployment environments. And then just because, the data science space is amazing in terms of the amount of tools, whether open source, vendor, that are out there. And so we think interoperability is a first-class design principle for any platform. And our at least our high-level shtick internally and with customers in terms of our design principles, building our platform, Snorkel Flow, has always been, we do want to provide comprehensive support for a workflow, and in particular, this data-centric workflow. So, over 62% of our customers use us for kind of end-to-end development of applications, start with raw data and get to some model, and they do that in Snorkel Flow. But we also want to make interop as easy as possible. So if you want to label your data in Snorkel Flow and then go train a model, in your own custom environment and do some model-centric iteration there, and then come back to do edits on your data, we try to make that as easy as possible too.
So last question for you from my side. You all came out of, I know that I got a buddy who just went over to Chris Ray's venture capital firm / incubator / everything machine. You all came out of there. How was it? Can you give me some background on what that was like and how it inspired you on what you're doing now?
Well, Chris is an extremely unique mad genius. He's one of the actually I can't give him too much credit on public record. I can't give him that much. So I'll say he's one of the smartest people I've ever had the fortune of working with. He was my advisor back at Stanford, and he's him and his group. It's a pretty incredible place. So this was back in the quaint old days when it was just the lab, no factory. But I could rattle down for a whole nother hour on things that I learned from Chris and from that environment, and continue to learn working with him. But I think maybe just a couple things here to tie it back to the themes we've talked about. One of the things that I think was pretty unique and is still with that group that I both resonated with me, which is why I gravitated to working with Chris, and then that I also took away was, the importance of, especially in a field like machine learning where there's so much, people churning up papers, there are new fancy methods every day. There's lots of there's lots of shiny things floating around, right? Chris and the people in his lab are geniuses at those pieces as well. The Snorkel team, the sub team that spun out, we've made our contributions on the theory and algorithm side, but the importance of just getting your hands dirty with real use cases end to end, that anchor point, being good on the principles, the fundamentals, the formalisms, but also pushing yourself to spend time just sitting with that genomicist or clinician or whoever is actually trying to build something, and actually taking the weeks, months, years to just see that through. We never would have started on data-centric AI if we hadn't been doing that, because we were thinking, okay, we're going to work on X fancy machine learning modeling technique, and our users kept saying, okay, no, we're stuck on the data. We just need to label the data. That's what's blocking us. Do you have any solutions there? It took us long enough, but you don't actually, I mean, it sounds trite, but I think it's true in this field. It's very appealing to, because of how we've set things up. It's wonderful for progress in some ways, but it's very appealing to just download a benchmark data set and try to build the fanciest model to get the score to go up, or to build the best cats on rocket ships, forcing yourself to actually work on real production use cases while also, doing your hard work to study, Abhi, those textbooks that you asked about in the background, that you recognized a couple of them that I will not confirm or deny if I've read every single page of the ones you'd referenced, but learning the fundamentals, but pairing that with just getting your hands dirty with real problems, real data. That was one thing I took away. And then I think Chris and that whole group, that whole machine, is very good at of balancing the two. Because if you just if you just look at real problems, you just hack away without trying to abstract and formalize and pull on lessons from everything in the academic and ML world we built up, then you also won't go the right direction. But if you just polish nice abstractions without getting your hands dirty, so it's that unique combination of forcing yourself to do both. We still try to do that with the company. We try to be very hands-on with customers, with new use cases, not just throw something over the wall. And that's one of many things, but one big thing I took away from that group that I'm hoping your friend is gonna take away and be excited about as well.
Incredible, man. This has been so cool, Alex. I appreciate you coming on here and expanding my vision of the power of foundational models and what comes next in the marriage of foundational models and MLOps, hopefully. This has been an absolute pleasure, and I want to thank you again for doing this.
Well, Demetrius, Abhi, thank you so much for the awesome conversation. Definitely one of the best I've had, because we started right away with the hard-hitting questions and got in the weeds. And yeah, pulling back, I mean, I think the two things I'd leave with are, I think, we talked plenty about it, but at a super high level, really simple things. One, data, surprise, and developing data is at the center of everything in AI, and it is, even more so the case. And that'll continue to come to bear with foundation models coming onto the scene. And second, there's a bunch of really exciting and really underfulfilled opportunities, which we're pursuing, but there's lots of room there to kind of bridge these foundation models with real use cases, existing real MLOps infrastructure and approaches. That's what we're excited to be announcing. There's lots of stuff to do there, though, so I hope other people kind of focus on that, because the generative exploratory use cases are awesome, and there's going to be a boom of creativity there that's going to be awesome, no doubt. But bridging it to these real production use cases is a massive white space right now, and so there's going to be exciting stuff there. And it was awesome to get to talk about it today.
Yes, I love it. Right on, dude.